Hi, it's me Jazzy. I'm back with another tech related video, and today it's a look inside. Now you might remember a video I did recently about an RS Components lux meter, and I commented how the case looked like it may have had other applications other than just being used for a lux meter, and other viewers spotted a similarity to the BT meters of that era. So I've actually picked up a couple since. This particular one's an SA9083 Mk. So this one today, we're going to get it on the bench, have a look inside. Now I've had this one for a few weeks. It arrived here a few weeks ago. I haven't really done much with it apart from put it on my shelf and admire it. So it's time to get it apart, see what makes it tick, and see if we can get it to work. So let's get this lovely little tester over on the bench and have a look inside. Right, so this is the one we're looking at today. This is the SA9083 Mk, which is marked as P.O, post office. The later ones have got BT or Telecom on them. Press for line reverse or test cells. Press for res ranges. Okay. So we've got battery test, earth, impedance times 100. Loop impedance. We've got DC 5 volts, 50 volts, 250, 50 milliamps, and 500 milliamps. That was a bit stiff. We've got our meter 0 there. Interesting thing though. So we've got some instructions for use on the back. Oh, excellent. So we need a shunt for extending the current range. So you put the control switch in S to use the shunt with it. Okay, that makes perfect sense. Tells you what leads to use, and we've got a 0 ohms and a battery test there as well. Okay, so you can see this is the SA9083 Mk. So it looks in pretty good condition, and I do have a bit of a fascination for these post office BT meters. So it all stemmed from the lux meter that I looked at recently, which was a RS Components lux meter here. Now we looked at this, and when I had it apart, I commented that the case had all these extra holes inside. And why did it have all these extra holes? It's clearly because they used this same case molding for multiple things, because all these holes here, there's a couple of slots here for switches, this all lines up with what is in the case. And there's also an additional hole here, which, okay, there's nothing on here, but we have seen other meters that do. So this is the one we're taking apart today, but I have since picked up a newer SA9083 as well, which is a slightly different design, nicely laid out, and you've just got one button there for test cells, and this has got the Telecom logo on it rather than the post office, although I have seen some with BT on them as well. And you can see they're all this same case moulding. And then one more that I've come across very recently that I haven't even looked at properly yet is this British Gas one. And it has another gadget that plugs in there for testing various things. I haven't even looked at this, but it seems to have more functions, and indeed we have another switch here where we found we had a hole on the original moulding. This one's unfortunately a bit yellow, and I haven't been able to find any instructions on it, but again, another interesting thing. This one's got a little bit of damage down the side here, but it doesn't seem to be so many of this British Gas one. There seems to be a lot more of the Telecom type ones around. One thing I did note, the difference from the lux meter, it's obviously not got so much circuitry inside, so it's a lot slimmer than the others. So although the front moulding is the same, the back moulding's completely different on these, but it does look to be pretty much standard between all of these. Now I believe these were made for British Telecom by GEC Alstom Protection and Control Limited. Now the warranty on this one runs out March 94. I get the feeling we may be out of luck on that warranty. Now the reason why I didn't want to take this one apart, it's still got the warranty void sticker on it, which is quite amazing. And actually, apart from a little bit of wear on this sticker, it's absolutely mint. And the other thing with this one, it came with the case. You normally find these appealing on the front. The Telecom logo looks excellent, even down to the strap. So whether this was just never issued and it had been in the stores for all that time, because it is absolutely minty fresh inside. And we have got, so there's a little bit of wear on this edge here. I don't know if that's just time has done that, but look on the, you can see they've still got chalk on the leads. It's almost like they were never used. In terms of collecting things, I always like to find stuff that's in mint condition. That one is really nice. This one is not bad at all. The British Gas one, unfortunately, has yellowed a bit over the years. Now, we'll take a look at the British Gas one in another episode because it's got another gadget with it, and I have to find some instructions on how that gadget works. So, the one we're looking at today is the SA9083 Mark 10. So let's make some room on the bench and get this apart, see what's inside. Okay, so some of these meters actually arrived here a few weeks ago and they've been hanging around in the background waiting for me to get a chance to take a look at them. So it's nice to actually get the chance to properly have a look at this. Enough supposition, let's have at it and see what we have inside this. I'm intrigued. Alright, well there's no batteries in there. Okay, all looks to be in reasonable condition. Fuse, spare, okay, nothing is present. Now, does that just pull apart? No. Feels like there's something more. I wonder if I'm needing to get this off. Ah, there we go. Now, that's why it's not coming apart. We need to get this apart. Of course we do. Ah, right, okay. Oh, it's one of those. Do I have that special tool to do that? No, I do not. Aha! It does. This is quite the lark, isn't it? I thought you'd just unscrew the back of the case and it would be that easy, but no. Gives me a chance to give it a good clean. Now, can we get in the case? Goodness me. Oh, okay, right. Oh, there's a lot going on in here, isn't there? Got to watch this wiring here. Right, let me move all these bits so I don't lose anything, because we're going to put it back together in a bit and give it a test. So we've got our meter movement in here, which is all very nicely enclosed. I haven't got to fiddle about with that at all. Now let's dive in and have a look. So we've got our main switch here. Got a little adjustment pot here by the look of it, RV3. I won't be tinkering about with that. There's our two switches. And we've got more trim pots. We've got two more here. Two up here. We've got a little one there on the right, RV5. Got an LED there, a couple of resistors, a diode. There's a 220 nanofarad cap. Couple of blue tantalums. Little rotors. Up in the corner there you got a ferrite transformer that ups the voltage, generating the 100 volt for the installation test. So it's seeing three transistors, all transistors, no ICs in here. This board must be fixed down in some way. Yeah, this seems to be fixed. I think it's fixed by means of this going through here. Is soldered to the board, I believe. Here, yeah. Oh yeah, there's two little nuts there. Well, we don't need to take it apart that much. It's just more of a curiosity thing, really. So while I'm here, I can remove some of the dust, give it a bit of a clean up, and then we'll find some batteries. Just need 2 AA's, and we can give it a test. Okay, that's looking a little bit better. So let's get that screwed through. There we go. Going to give this a good old clean before we put it back together. Okay, now we know what's inside and it's a little bit cleaner than it was. Let's get everything back in one piece. So this just screws on. I believe there is a special tool for this, but unfortunately it's not a tool that I have. Now this only goes on one way, so we can't really go wrong with that. That's it. That's good. So there we go. Lovely. Okay, so that's all good. Now let's just get the screws back in the back, and I'm going to have to find something to stick the two little rubber feet back on that came off during my dismantling process. So it's fairly simple inside, really, but if you've ever wondered what's inside a post office test meter, now you know. I didn't know. I've never taken one apart. Never had one until now, really. I've got to find a couple of batteries though. At least the terminals aren't corroded. Okay, so let's put some batteries in this and see what it can do. Don't know what I can test with it, but let's give it a shot. It's not really an everyday kind of multimeter, is it? I always think it's fun with these old meters. It's not just about having them and putting them on a shelf to enjoy it. It's also about having a bit of a tinker with them, really. So some of the functions on here are designed specifically for telephone engineers, linesmen, testing phone cables for shorts and insulation problems on analog phone cables. Now, that's not really something I'm going to be testing today. So there are other functions on here that we can look at that can still be relevant. So you can see the differences between the two models here. This is the older one, which we've just taken apart, and this is a much newer model. This is a Mark 10, this is a Mark 14, I believe. And I think the newer ones, I think they went up as far as Mark 16 or 18, I can't remember now. And the newer ones were made by Robin, and they're a little bit of a different form factor to these, but basically all the same functions. So they've simplified it on the newer one and they've color coded it, but we've still got the same sort of functionality on here. So you can see that the off is the 250 volt AC, same on there. So the reason these are marked as off for this particular position, it's the only position of the switch where the battery is not in circuit. So leaving it on here, you're not going to run the battery down unnecessarily. So basically what they've done is they've taken a multimeter and just given the functions that you need to test phone lines. So you've got a couple of specific ones here, BAT B and Earth B, and they're specifically for testing phone lines. So you've got a switch here for the B to A changeover, which I think you've got here. So you clip your probes to the legs of the test line and your earth to your earth. For instance, it says battery B, earth B, so you'd test leg B and then you'd hold that in to test leg A. That probably doesn't mean anything to anyone that's never tested an analog phone line. The BAT B would be for checking for any stray AC voltage on the line before you start testing, so you don't damage the meter. Then you've got an earth B as well, which is for checking for any earth contacts on the B leg of your analog line, and again you'd hold that in to check the A leg. So basically when you're doing those kind of checks, if your meter doesn't move, then you're all good. If it moves, then you've got some problems on the line that you're checking. So in that case, if you know your meter's not going to move, if you've got a problem, then you have to check the meter out first. So let's just have a bit of a play. Now we've got these meters. This one's batteried up. And they basically work in the same way. It's just that this one's been made a bit easier to read. So when you're out on the job, you can read it a bit easier. Now these are the test leads which came with this meter here. And you can see they are sprung banana cables. Very nice. So I'm going to use these for testing. It seems appropriate as we've got these here. So A plus, B minus, and earth. Okay. And we've also got some probe tips here. This is rather convenient, isn't it? So let's pop these on. It's a little bit bent, that tip, but it's okay. This is just for fun, of course. It's a shame that these meters are largely irrelevant now, because analog phone lines are a thing of the past now. So in order to test, so we're going to turn this around to the ohms loop function. With this one, if you turn this to ohms loop, then you're good to go. But with this one, you've got to press this one in for the resistance ranges. So we're in ohms loop mode, resistance range is on. So when I touch these, the needle should swing around to the end, which it does. That's it. That means your battery is good. So generally you do that test before you start testing your phone line, because then the next couple of tests that you do, these bat B and earth B, this needle shouldn't move ideally. So this is how you tell you've got a good battery, because if the battery's not got enough power, it won't be able to move the needle right to the end of the scale. So if the needle's not going right to the end, then the battery is no good. And you've got a 100 ohm range on here as well, which was used in checking analog phone lines. And that was for checking any contact between the A and B leg of the phone line, so like a high resistance loop. And then you'd hold down this one to check for a polarized loop in the line. Right, so you've also got this megometer function here as well, which is very useful. And this was used for testing the insulation of a phone line, a little bit like the insulation test that we looked at recently. This tests the insulation at 100 volts, and again you could switch between the A and B leg of a phone line with this here, or with the B to A change button on the more modern one. This is a lot more springy. I don't think this meter's had hardly any, if any, use. This one's clearly had a lot more use. The other use of the ohms loop function would have been to check for a break in the cable, which would generally have been done with the A and B legs of the phone cable together. I'm not an expert on checking analog phone lines, but I have a vague understanding of it. Apparently, if we go on the 100 ohms range, there's various other tests we can do. So there's still some functions on this you could use. I think it's fun sometimes just to have a play around with these things, see how they would have been used. You can also see, the other thing that I'm really noticing on camera is the way I've got the 3 probes in here. You can see that's how the 3 probes would be, but you know those two holes in the case are still going to be under there, aren't they? They've simplified it and made it just easier to read, haven't they, in the newer version? But this still does all the same functions. So in the high ohms range, which is here, with the probes touched together, the pointer should indicate 0 ohms. And it does. So similar to what we did with the battery test. Now apparently I can use this to check a capacitor. How fun. Let's do that. Let's try this theory. It's a 10 microfarad capacitor. Right, so if I press the BA change button, if it's a good capacitor, the needle will swing back down to 0. When I release that, you see it swings to the end and then comes back. Depending on the value of the capacitor, you can see where it stopped there. This is a 10 microfarad cap. If I grab a smaller value than that, alright, let's go for a 2.2 microfarad. Now some of these tester leads had crock clips, which would be far more practical. So if I press the B to A change, there you go, kicks up, drops back down, tells me that capacitor's alright. So for a quick and dirty capacitor test, you could do that. That's pretty cool, huh? See, on the older meters, you've got the option to use a shunt as well. And it does tell you on the back there to use the shunt for extending the current range. So if you're measuring current, you can do that. Let's try some DC volts. Let's take the probes off. Good fun, this. Who knew that a BT tester could do so much? It's quite cool. I won't go through all the functions or I'll be here all day, but let's try it with a bit of DC volts because it's quick and easy, isn't it? Got a power supply right here. So I'm on the 50 volt range, so let's start off with 10 volts. Oh yeah, that's pretty spot on, isn't it? I like that. Alright, let's go 15, 20. Yeah, it's doing it, isn't it? 25, 30 is all I got on this power supply. That's pretty good though. Oh, got to be happy with that. But yeah, there's other stuff you can do on it. You've got current ranges, you've got some milliamp ranges there. So they've still got uses in this day and age, even though you wouldn't really use them for testing the phone line functions anymore. I find it fascinating how they used to test the analog phone lines with these. And I love the progression of these from the older ones like this to the newer ones where they're a bit more health and safety-fied, and they're a bit more easier to read, easier for new people coming in to learn them. I'm not taking this apart because it's still got the warranty void sticker on it. This one, we know, works absolutely fine. And apparently if you're measuring current with this and you've got your probes reversed and you're getting a negative current, you can just use this BA reverse button to get a positive reading. That's quite cool. Now, one thing to note though is these meters use the smaller size banana plugs. The standard size won't fit these. These are the smaller size ones, and I do like these sprung safety ones. They're pretty cool. But there you go, SA9083 analog phone line test meters. I think they're pretty cool, and it's nice that these are in lovely condition, a great addition to my collection, and they're a little bit of fun to play around with, aren't they? So there you go, the SA9083 Mark 10 post office tester. Lovely little bit of kit that is. I really enjoyed taking a look at that one today, and it's funny how they've managed to use that same casing design for so many different things. So we've seen there's at least 3 or 4 different post office, GPO, British Telecom type meters. There's a couple of different Lux meters I've seen using the same casing, and of course we've got our British gas meter to take a look at as well. I'll do this one in a future episode because we've also got this other device that plugs into it, so we need to take a look at that and investigate what that can do. So I hope you've enjoyed this video today, taking a look at this lovely little post office meter. As always, massive thanks to everyone for watching, sharing, liking, commenting and subscribing. If you'd like to go ahead and hit the subscribe button, it's always massively appreciated and helps to support the channel. I'll be back soon with some more tech related videos, but in the meantime, take care and I'll see you on the next one.